Welcome into the Protopod, the show where we talk to the innovators, engineers, and entrepreneurs who are shaping the future of technology manufacturing. I'm your host, Jordan Rose. Today on the Protopod, we're joined by someone whose fingerprints are on some of the most important spacecraft systems of the past 4 decades. Joe Cavazos is an embedded electronics designer, spacecraft avionics architect, and founder of HoustonMicro computer company. Joe began his engineering journey at just 20 years old at NASA's Johnson Space Center, where he spent nearly 30 years designing flight and ground systems for ISS, Orion, and major NASA communication upgrades. Since 2014, Joe has been an independent consultant helping emerging commercial space companies, as well as medical device innovators, design high-performance FPGA systems, avionics architectures, and mission-critical test equipment, all from the hotbed of aerospace development in Houston. We're excited to dig into his career, the rise of commercial space, and how small teams can build world-class electronics with the right tools. Joe, welcome into the Protopod. Joe, welcome into the Protopod. I'm really interested to chat with you today. I know you have a very long history in science and technology. Do you want to start by giving myself and the listeners your origin story, I guess, so to speak?
Yeah, sure. So I live in Houston, Texas, right, and right around the corner from the Johnson Space Center, and the Johnson Space Center is kind of when I started my career back in 1986, back in the 1900s. So I was 20 years old. I was an avionics electronic technician on the space shuttle program. That was my first gig, which was kind of strange for me because I worked at a car wash before. So I went from washing cars, got my 2-year technician degree, and then suddenly I'm at NASA, 500 miles north of where I'm from South Texas. So I kind of started with the space shuttle program, working on avionics systems as an electronic technician, and kind of took advantage of their tuition reimbursement. I went to night school at the University of Houston. So that took forever, and kind of got my engineering degree in the 90s, mid-90s, and moved into engineering and design. And it's just kind of kept going, really. And it's one of those things you don't realize what's coming ahead. You just kind of follow on what the next project is, and before you knew it, you're working on bigger systems, and then all of a sudden you're a spacecraft architect and lead engineer on new spaceships, including the International Space Station, and others. So I just kind of kept going, and I really love that kind of work. So that was a big motivator, just enjoying the work, and eventually kind of went out on my own, started my own company, HoustonMicro, and doing consulting for startup companies, right, that are doing things like lunar landers, robotic lunar landers, and new space stations, commercial space stations. That's kind of where I'm at now, as a founder of HoustonMicro Consulting, and helping other companies, in their flight system designs for the spacecraft and their ground systems. I just kind of never stopped. And so 40 years later, I'm sort of still doing it, but they're, now as a consultant, as an avionics architect, kind of engineer.
Yeah, that's it's an incredible story. Obviously somebody with a tremendous amount of drive, both working and going to engineering school, which I can only imagine how difficult that was, and then also moving up through the ranks and taking on more and more challenging projects at NASA. I'm curious, you mentioned that you're now in the consulting world with HoustonMicro. What drove you to make the transition from working with NASA and I believe Lockheed as well, and move into the consulting world?
So out of that 35-ish years, 19 of it was with Lockheed. So, I mean, that was a huge learning experience, obviously, right? It's one of those things where I just had a little idea of some processing systems that I thought, nobody seems to be interested in it. So I went ahead and designed it and had some manufactured and built, and just built these units. And incidentally, that's when I discovered Protocase because I needed to put these things in a chassis. And so I built these systems to test spacecraft, uh, more like ground support equipment. And so I just did that because, I just enjoyed doing it. And apparently I wasn't getting enough of it at work. So I just went and started this. And then one day somebody finds out about it, a new startup company. And they, hey, we're looking for somebody who can help us design some electronic systems. I go, I know a guy who knows a guy that started a company. And so I get this phone call. And so okay, let me try that. And so I kind of did some part-time work. And that company ended up designing lunar spacecraft eventually. So when I had that gig for a little while, wasn't able to leave my day work, and then all of a sudden he said, "Hey Joe, we got a big project we're going to propose. We're going to go back to the moon." And I kind of wasn't sure I actually believed it, but I said, "Why not?" And so I joined that project, and then that was all encompassing. So then it was profit positive, became self-employed at that point, and I just never looked back. And from that, you meet people, you network, and then you end up getting another contract from another company saying Colorado. I can't tell you what their names are, but designing a commercial space station or two, and flight computer. And then from that, you get another contract. You just, the phone just rings. I don't have to advertise it. So it's a small niche, it's a small circle of people who design spacecraft.
I bet.
And so you end up knowing everybody, right?
No, I love that line. Why not go back to the moon? Yeah, it's great. So you touched on it in there, that it all kind of started with, it was very organic, and starting from building test systems, on the ground test systems, kind of out of your home, and then translating that into the startup world. I'm curious, with that work, test systems and their importance in I guess testing complicated systems, whether it be on spacecraft or aircraft or what have you. Do you want to touch on that niche and why that is such an important aspect that can sometimes be overlooked in the building, design and build process for these types of systems?
Yeah, definitely. So I started out in the space shuttle testing world, and for development of a new flight computer. Remember, that's what I was doing when I was 20, and so I immediately had an appreciation for what it takes before anything gets launched. I mean, during the development, the conceptual stage, and then the proof of concept testing, prototyping. You have to do that. I mean, and I see, and I understand what you're saying. Sometimes it gets to be a little minimized, if you will, because of funding constraints or schedule constraints. But it's really more expensive to find out when your ship is in space where you can't really fix it. So you have to do it on the ground, and you have to do extensive testing. And that's just the way I grew up. That's the way my former employers, back in the 80s and 90s, that's just the way it was done. And, with the rise of commercial space, funding is way more limited, right? We're talking companies with limited venture capital. And so it's easy to want to minimize and overlook the testing. But, when these kind of conversations come up with my clients, I always say, yeah, I think you want to do this. It's cheaper. You're not using space grade parts, and to develop a test system and really, really stress the system out here on Earth when you can do something about it, and you don't want to find out these, you don't want to discover these problems, and there's going to be problems. I mean, this rocket science. You're gonna find some things you weren't expecting. You want to do it down here, not up there.
Yeah, I absolutely. I mean, we talk about that on the show quite a bit, that there's always these unknowns that pop up, and you can never predict any project perfectly. And it's a testing, whether that be in project development or of the final system, which is a part of that, is absolutely critical to minimizing your cost and your risk overall. I'm curious. Obviously, you've outlined kind of the broad spectrum of the work that you've done, from the big picture space system view all the way down to some more detailed work on specific systems, a custom processing board or what have you. I'm wondering if you can give me an idea of what you might have learned from a project development perspective. What kind of core tenets or methodologies do you use that apply both on those large scale things and on the small projects?
So there's probably, there's several areas that you kind of over the decades you kind of become aware of that you kind of knew it, but then you really see it when you've done this 30, 40 years, right? And that really the whole process, the whole organic system goes both ways. You have to really know the devils are in the details, down on the circuit board level, noise, good board design, circuit board design. Um, those things trickle up and become problems at the top level when they're not being looked at the top level. But at the same time, if you're down in the board level, circuit design level, you might not see the bigger picture of what's coming, the environment you're going to be in, other systems that are interfacing with you, with your little part. And you start to realize you have to start. I love starting with a blank sheet of paper. That's my favorite thing. Um, but you have to look at it from the bottom, almost the atomic level, the electronic level, and then you also have to look at the whole spacecraft, the whole um, avionics architecture. And because I've been both, I've been lucky in my career that I can do that. So a lot of times, let's say there's a project, you start out as an architect, an avionics architect at the top level. But in the back of my mind, I'm looking at all these little tiny details from the bottom. They're going to come and bite you. And you can discuss this with, your team, and the other way around. Uh, you have to look at it from both ways. You have to really own the whole thing down to the electronics, atomic, I call it, to the top architectural level of the spacecraft. That's kind of what I learned over
Yeah,
the years.
I know. I really like that. It's the idea of different lenses and how they kind of feed each other. The top down and the bottom up, and how the bottom up kind of drives some decisions, especially talking about unknowns or things that you had to look out for.
Exactly.
The structure of your project from a big picture level really has to come from what details you think are going to bite you. And I think that's a really great description.
Yeah, and I think the other thing I learned is, and this is when I worked on Orion, which is the lunar crew module. It already went up, orbited the moon, went past the moon, and came back and landed. Um, that was a long, long design process. I was there at the very beginning during the initial architectural phase, and those kind of things were happening. But that was sort of my first real ownership of a part of a big design. And because I used to be a control freak, I used to want to design everything. What I learned, because that was horrendously complicated, was you can't do it all by yourself. So I finally went to my supervisor and said, I need help. I think this is a bigger team than two people. And, they agreed. And eventually a team was built. And that's when you started learning this thing about building a team, finding these rock stars that, and you delegate, you're good at this. I'm not. Please handle this and have, but keep it a small team too. When you have too many, cooks in the kitchen, that can be restrictive. So having just a big enough small team at the beginning during the creation phase, I think that's an important thing. That's the other thing I learned, and I was over being a control freak at that point because you can't do it by yourself.
Yeah, no, that's a really insightful. So obviously, that idea that different people have different strengths, and kind of leveraging that for the betterment of the group. I'm curious, like on those types of projects, what does the collaboration look like? When maybe things are scaling out from your small team to other small teams. How does that work, and what are some of the things that have, I guess, bitten you or you've had to deal with in the past?
Oh, there's always something that's going to bite you. But when you start getting into the first implementation phase and prototyping, that's when the realities kick in and these things start happening. And now you got other teams involved, propulsion, say, or um, you know, command and data handling and communication systems all intertwined. And that's when I go back to, at some point, an integrated testing system, right? Where you start slowly, iteratively connecting with all these other parts of the spacecraft system and testing system and software systems. And you start to build that up in parallel. Because you can't really, trying to be in it's nice to try to stay in your vacuum, your own little world, but at some point you have to start integrating with the bigger picture, but start slowly. I think that's important. Um, that integration of varying systems, propulsion is very different from avionics, very different from software, very different from communications, right? But you need to start doing it at some point because it's all going to come together on the launch pad. So you need to start doing that as early as possible. Um, that's always a challenge because especially in commercial space, there's not a big amount of funding usually. It's venture capital driven partly. Maybe some government support, but it's commercial. So it's not like the old days, like Apollo, where you had, the United States government was everything. Now you got to somewhat show progress and viability, right? So I think integrating a system and an integration test philosophy from the very beginning needs to happen at the same time.
Yeah, no, again, it's just a topic that comes up so much. That idea of kind of getting to that what we would call an end-to-end moment. That's our language for integrated testing and bringing things together, as quickly as reasonably possible and testing it. Your full system will give you the answers to kind of where you're at and what things you need to work on. So I think that's an excellent point. I'm curious. I know that you had mentioned Orion, and there's obviously a massive number of fascinating other projects that you've worked on. I'm wondering if anything stands out to you as your favorite or most interesting during your career that you would be willing to kind of expand on for the audience.
Most of these projects I've worked on have been pretty challenging, and that makes them, you know, I like that. But I mean, I guess working on a commercial lunar spacecraft with a blank sheet of paper, uh, being one of the avionics architects for that system, which means the computer system, the communications, the transponders, the antennas, and that whole system, and then, within 3, 4 years, I think seeing that thing on the moon, that was that. I guess I was in denial when we were working that because we hadn't really been back to the moon since Apollo. You know, granted, this is non-human spacecraft, but still, our stuff is on the moon. So that right there is going to be hard to beat, right? But that one is up there. I also, had to design a pretty complicated processor board for a medical device company out of Boston. Um, so that was the other extreme down, like you were mentioning, down on the detail level of board design. They had quite a bunch of complication on this multi-layer board that had a processor, external memory, multiple interfaces. So that I kind of like it because I can stay at the top level as an avionics architect, but still get dirty down in the circuit board level. So I like that one almost just as much, actually.
Yeah, very interesting. So that blend keeps you kind of engaged at all your skill sets engaged, and in that way it's enjoyable. That totally makes sense. I guess a little bit more broadly, what excites you the most about the aerospace industry, or the space landscape these days? What are you most interested in?
Well, there's this big push for commercialization, right? And it's all over the country, but in this zip code right around Johnson Space Center, there's easily 15, 20 startup companies, easily. They all have a vision, and they've decided to take the risk, take the leap. And there's a bunch of founders out there starting their vision. And you know what it kind of reminds me of, because I'm also a musician, an amateur musician. It reminds me of I used to fantasize I wish I lived during the 1800s where I could be in Vienna and be around all these great composers. And Vienna was the hotbed of all that stuff. And then how cool it would be to live during that era in the center of gravity for music, classical music, right? And then I realized, that's kind of happening right here in this zip code around NASA Johnson Space Center. This is where a lot of the startups and innovation is happening. There's a company called Ad Astra Rocket Company, and they've been designing an engine to go to Mars. That's all they're working on. It's an ex-astronaut, and he decided to go out on his own and start that company. There's 15, 20 more that have their niche. And just looking at that around me here in this part of Houston, it's kind of cool. It's like the Vienna of space.
No, that's incredible. That's what I was going to say. Is it sounds like you are in Vienna. That's really, really inspiring, and I imagine keeps you very busy. Yeah, it looks like you found yourself in the right space with HoustonMicro.
Yeah, and it's interesting because I really wasn't planning to start my own company. I was pretty happy just being a designer for on the NASA side. And it's still, NASA Johnson Space Center. That's still the great grandfather that kind of started all of this, right? So, it's kind of neat to see this new generation of entrepreneurs, and it's all around here, and there's, like I said, there's other areas in the country that are doing it too, but there's a lot of it going on right here.
Incredible. Joe, before we conclude, I wanted to run you through our rapid fire segment. Rapid fire questions, first thing that comes to your mind. Are you ready?
I hope so.
Last movie you watched?
Last movie I watched, I don't watch a lot of movies, to be honest with you, but that's a good one. Imitation Game.
Okay, good
Imitation
one.
Game.
Your number one hobby right now?
So I play bass in a disco band, and if you want, I'll send you really incriminating photos of me in 1970s stage attire, playing my piano. But I've also gotten into smoking briskets and barbecuing. So I'm gonna have to say those two are tied for number one.
Okay, both very good. Coffee or tea?
Coffee.
Coffee. Another great answer. The correct one. The best advice you've ever received?
Oh, that one I know. So you remember back in 1986, 87, I was 20, 21. I was a technician. I had a 2-year associate's degree. And my supervisor was with me in a 24-hour test. He had to be there. Somebody had to be there. You can't have just one person in a building, for safety reasons. And I told him, I goes, I'm considering going to night school and maybe pursuing my engineering degree. But I have this full-time job. If I do it part-time, it's going to take me 7 years part-time. And this is what he said, my supervisor. His name was Marv. He said, well, Joe, how old are you going to be in 7 years if you get your engineering degree? And I said, I'm going to be 29. How old are you going to be in 7 years if you don't get your engineering degree? And I said, 29. And that changed everything, because basically it's like what he said was 29 is coming whether you do something with that time or not. And that's when I stopped looking at the number and just slowly decided, I'm going to be an engineer, and I'm going to take 6 hours at a time, and it's going to take me a long time because it's part-time. And then before you know it, I'm 29, I'm graduating, and you know what? I never stopped. I kept going. I got my master's degree. I'm currently pursuing my doctorate at the University of Houston. And I remember his voice, because when I decided to get my PhD, I was, oh man, I'm already old. And then I remember Marv, speaking those words of wisdom to me. He's like, well, you know what? I'm going to go ahead and do it.
That's awesome advice. I think that perspective is really, quite powerful in those moments. And I think, that's an awesome story. I think also a great way to end it. Joe, if folks listening are looking to learn more about HoustonMicro, where can they find out more?
You can go to the website. It's HoustonMicro.com. And there's sort of a summary of past projects, capabilities. Also, you'll find, email, correspondence addresses, that kind of thing, phone number.
Awesome. Joe, thank you so much. Been great chatting with you and learning more about your career and your advice for engineers and anybody interested in the tech space on how you kind of walk through projects and and go to the moon. So it's been a pleasure.
Yeah, thank you so much. I really enjoyed this, and thanks for the invitation.
Awesome. Thank you, Joe. Until next time. Bye-bye.
Okay, bye-bye.